This is lesson 3.3, present value. This is a grade 11 college lesson, so if you are in grade 11 college, this lesson is for you. The learning goals of this lesson are that we are learning to solve for the value of P in compound interest problems. So we were in 3.2 solving for the value of A, now we're solving for P. It's a little bit different. And we're also learning to solve equations with negative exponents, which we did a little bit in in unit 2, and we're going to continue with it here. So just a reminder from lesson 3.2, we've got this crazy equation that we learned is not so scary after all. And remember that this is the equation that we use to calculate the total value of an account or borrowed money with compound interest. So in 3.2 we found A. So let's just review what each of these letters stand for. So you can review our notes from 3.2, and I'm just going to orally describe what each of these stand for. A, remember, is our accumulated value. So it's the value at the end of that 10 years. Let's say you put in $1,000 into a bank account for 10 years. It's the amount of money that you've got at the end of that 10 years. P, remember, is the principal. It's the initial value. So if we put in $1,000 at the beginning of our time, that would be our P, our principal. Then we've got I, which we know is the interest rate. And when you're reading the interest rate off from a question, you might have to divide it by a number depending on how often interest is compounded. And then we've got our N, which is our number of periods. So we've got the four variables that we look for. I want to quickly talk about present value versus future value. So I've talked a bit about future value in lesson number 3.2, but today we're going to focus on present value. So present value, and copy down these notes. You should have notes, the notes page 3.3, present value. If you don't have it, please go pick one up from me, because these notes this lesson is going to go along with those notes. So just a reminder, present value means the value of your money today. And future value, therefore, is the value of your money in the future. The value of your money in the future. So if we are going to use these letters here that we've got up here, which of these letters would be present value and which would be future value? Well, I think that we can figure out what the future value is. It's definitely not I, that's interest rate. Definitely not N, that's the number of periods. But A, remember, is the accumulated value. So we said that last time, accumulated value at the end of the periods that you're investing this money. So A is our future value. What is P? Well, I'll give you a scenario. Let's say that you put into the bank, you get, for your birthday, you get $100, and you're going to put that right into the bank and let it sit and collect interest for 10 years. But today is the day you put it in the bank. So what is it worth today? Well, it's just worth that $100. So it's just worth whatever your principal is. So the present value of your money is just P, which is the principal. So if we're looking for the present value of our money, that means we're just looking for P. And if we're looking for the future value of our money, we're just looking for A. So let's do some examples to show you the difference. So let's read example number 1 together. Example number 1 says, Sam wants to invest enough money today to have $3,200 for tuition when he goes to college in 2 years. If he invests his money at 6% per year, compounded monthly, how much does he need to invest? So as soon as you see the word compounded, we know that we are using the equation A equals P times 1 plus R to the power of N. So we know we're looking for A. We're looking for, actually let's pick another color for that. We're looking for A. We're looking for P. We're looking for R. And we're looking for N. So let's fill in these things. So let's hold off on A and P, and let's just go right to, oh, instead of R, I should have put I. I don't know why I put R. I was thinking simple interest. Let's put an I here and an I there. Okay, so before we deal with A and P, let's deal with I. So this is just from 3.2. We can clearly pick out I is 6%. So we're going to write 6%. But we can't just leave it like that. We have to see how often our interest is being compounded. So we can see it's being compounded monthly. Okay, so I'm going to go back to the chart from 3.2, check what do we do with I when our interest is compounded monthly. And you're going to remember that you actually have to divide it by 12. That's what we're going to do. We're going to divide that by 12, and we'll get 0.5%. Don't forget that percentage. How do we change percent to a decimal? We divide by 100, and we will get 0.005. All right, let's do the same thing for N now. So N we know is the number of periods. So let's look when I see 2 years. So we know that our N is 2. But don't forget it's compounded monthly, so go back to the chart, check what that means to the number of periods. We're going to have to multiply by 12, which is going to make 24. So we've got I, we've got N. So now we've got to figure out whether we have A or we have P. So Sam wants to have $3,200. Does that mean he has it now, or he wants to have it in the future? If it's in the future, we know we're looking for this one. If he has this money in the present, we know we're looking for the principal, the amount he can invest right now. So because this is the amount of money that he wants in the future, we know that this is A, the accumulated value that he wants at the end of the 2 years. So we have A. We know that he wants at the end of the 2 years $3,200. So what we're really looking for is P. How much does he have to invest right now, today, in order to have $3,200 in the future, right before he goes to college? So we are searching for P now. So now that we've got our A, and we've got our P, we've got our I, we've got our N, or sorry, we're looking for our P. Let's plug it into the equation. So just as a reminder, here's our equation. A equals P times 1 plus I to the power of N. So let's plug in what we know. We know that A equals 3,200, so we're going to write 3,200. P equals, no idea, so we're going to write P. Then we've got 1 plus, what's I? 0.0505005, sorry. And what is N? N is just 24. So let's start to simplify. I don't want you to simplify this exponent yet. I'm going to show you what I want you to do. The only thing I want you to do is simplify what's in the bracket. So let's rewrite this as 3,200 equals P times 1.005. We're just adding those two. 1 plus 0.005 is just 1.005 to the power of 24. So now we're going to use some of the algebra skills that we looked at in unit number 2, which is we've got to isolate for this P. This is what we want by itself. So we've got to get rid of this entire thing here. So what we have to ask ourselves is what is happening in between this P and this big blob? Well, this is multiplication. So how are we going to get rid of this entire thing? We've got to do the opposite, which is divide. So let me erase all my scribblies so we can see this. So that's exactly what we're going to do. We're going to divide by everything that we want to go into the other side. So we're going to divide by 1.005 to the power of 24. Whatever I do on the left, I better do on the right too. So we're going to divide by 1.005 to the power of 24. Now on the left or on the right hand side, we can cross this out and cross this out. So that on the right hand side, we've got 32, oh, let me change my color. 3,200 divided by 1.005 to the power of 24 equals P. So all we have to do now is plug this into our calculator, and we should get that P equals 2838.99. So check in your calculator to make sure that you've got that answer. Pause the video until you know that you've got it. So remember what the question was asking. Sam wants to have $3,200. So he wants $3,200 at the end. He's asking now, how much do I need to invest right now if I want this amount of money? So we just found that he's got to invest this amount of money. He's got to invest a principal of $2,838.99. So we've got to answer this in a word problem with a sentence. So Sam, we'll put a little therefore symbol, therefore, Sam must invest $2,838.99 now in order to have, how much money? I can't remember. $3,200. In order to have $3,200 before college. So let's do another example together. All right, example number 2 says, John has a loan for $5,000 that is due in 4 years. He wants to pay off his debt early. The creditor is willing to discount the loan at an interest rate of 8% per year, compounded semi-annually. How much would the creditor be willing to accept today? So first, I see the word compounded. So I know I'm dealing with our favorite equation, A equals P1 plus I to the power of N. So I'm going to write out all of our variables once again. So we're going to write out A, we need to find P, we need to find I, and we need to find N. So let's do the easy ones first, which is interest rate and number of years. So we're looking for the interest rate, and I see, boom, percentage, 8% per year interest rate. So I'm going to write 8%, but I cannot just leave it like that. I've got to look how often are the creditors compounding interest, and I can see that this is compounded semi-annually. So go back to our chart from 3.2, and you will see that if we are compounding interest semi-annually, you take this interest rate and divide it by 2. It's going to make 4%. We're going to change that percentage into a decimal, so we're going to divide by 100, and we're left with 0.04. And now let's do N. So we're looking for N, the number of periods. Where do you see the number of periods? Well, he's got to pay this loan off in 4 years. So there's our number of periods, 4. Take a look at our chart. What do we do with N when interest is compounded semi-annually? We have to multiply it by 2, which makes 8. Okay, so we've got our I, we've got our N. Now we have to figure out whether we have A or P. Now do not forget, A is equal to the future value, so FV, and P is equal to the present value. So do we have a future value or do we have a present value? That is the question. Let's read it out again. John has a loan for $5,000 that's due in 4 years. So the amount of money that's due in 4 years is $5,000. So at the end of 4 years, he's got to pay $5,000. So what are we given, the future value or the present value? If John has to pay this amount of money in 4 years, that means we are given the future value. So we're given the future value of this loan. He's got to pay $5,000. Which means that we're looking for the present value or the principal, which makes sense because the question says that he wants to pay off the loan early. How much would the creditor be willing to accept today. Today is the key word. So how much, if he wanted to pay this off early, how much would he have to pay today in order to be free of this loan in 4 years? So we're looking for the present value, today's value, or what he should invest or give today. So we're looking for P. So let's plug this into our equation. Once we know what we're looking for and we've got all of our variables solved, the hard part's done. So now we're just doing some calculator work. So we've got A equals P times 1 plus I to the power of N. Let's fill in what we know. A we know is $5,000 equals P is equal to no idea, so we're going to just write P. And then we've got 1 plus I is equal to 0.04. And then we've got N bracket. N is equal to 8. And remember that we are trying to find P on its own. So how do we find P on its own? Well, we got to get rid of all of this stuff right here. So let's do that. So we are going to divide by 1 plus 0.004 to the power of 8. Whatever we do on the right side, we better do on the left side. So we're going to divide by 1 plus, oh, you know what? Before we do that division, let's do this. Sorry everyone, make you erase. Let's just make it easier for ourselves and let's simplify what's inside that bracket. So I thought I wanted to do that first. So we're going to rewrite this as $5,000 equals P times, let's simplify 1 plus 0.04, just 1.048. And now let's get rid of this. So to get rid of a times 1.04 to the power of 8, we're going to divide. 1.04 divided by 8. Whatever I do to the right side, I better do to the left side. We've got 1.04 to the power of 8. We have something magical that can happen on this right side, which is 1.04 to the power of 8. Cancels each other out. We've got times and then divide by the same number. So we are left with, on the right hand side, 5,000 equals 1.04 to the power of 8 equals P. So now plug that into your calculator and you should get the answer. $3,653.45. If you do not have that answer, please go back, check to make sure you punched it in correctly. If you're still not getting the right answer, please come find me. So let's answer the question that was asked of us. Oh, making a line here. Okay, so it asked us, how much is John willing, or sorry, how much is the creditor willing to accept today for his loan that's valued at $5,000 in 4 years. So John wants to pay his loan off early. So we can say that the creditor would be willing to accept $3,653.45 today instead of paying back $5,000 in 4 years. Instead of receiving $5,000 at the end of 4 years. So the only thing different in this lesson from the previous lesson is that instead of looking for A, we are looking for P. That's the only main difference. As soon as you figure out whether or not we're looking for A and P, and you figured out what I is and you figured out what N is, the hard part is done. The rest is just plugging it into our equation, which we have, and doing some calculator work to answer. Do not forget, at the end of these questions, you should have a sentence finishing them off. So now we're going to do some examples as a class, but before you do that, I have an activity for you on Edmodo using some credit card and debt calculators. So please go onto Edmodo now and try it out. Then I want you to try some examples on your own to make sure that you've got this down. back to our learning goals. This is what you should have learned how to do after this lesson. So remember that we learned to solve for the value of P in our compound interest equation. And we learned to understand the difference between the present value of our account or a loan and the future value of our account or a loan. So now please go on to Edmodo, try the activity, fill out the answers that you've got, and then try some examples on your own.